Hi, so today I'm going to teach you all a new topic called energy audit of building. Now you people must be aware of this term audit. You might have heard financial audit, which all the companies have right at the end of the financial year to check about all the resources, whether they are spent effectively or no. Right? Similar thing we do with energy. Alright? So what is exactly energy audit? Energy audit is a periodic examination of energy systems to ensure that energy is being used as efficiently as possible. So it's actually a feasibility study. We are trying to find out whether energy is being used properly or not. Now, where will you find energy being used in a household? It will be used in your kitchen, right, in the form of your mixer grinder, in your washrooms in the form of a geyser or a washing machine. We are specifically talking about residential buildings, so we're not going to talk about anything that is pertaining to industrial sector, right? So now when we are doing energy auditing, we will assess each and every point where energy will be used, may it be in our heating appliances or cooling appliances, or maybe as cooking gas, right? Or maybe even the energy that is used to pump in the water. That's why even water conservation automatically becomes a part of energy conservation, right? Now why do we require this energy audit? Now let's have a look at this statistics that I found on internet. Now if you look at this picture, you can see sector-wise composition of commercial energy. 10% goes in the residential sector. Okay, transport is taking 22%. So it's basically in the form of fuels that are consumed for transportation. Agriculture takes 5%, and 49% is taken by industry. Now, what we are trying to understand is the energy consumption in this 10% of residential sector. Now have a look at this statement that I found on, if I'm not mistaken, it was a paper, research paper. So electricity consumption in Indian homes has tripled since 2000. Tripled. Okay. Percentage of households with an access to electricity has increased from 55% in 2001 to 80% in 2017. 2014, an electrified Indian household will consume 90 units. Remember this number, 90 units of electricity per month on an average. Enough to run 4 tube lights, 4 ceiling fans, a television, a refrigerator, and a small kitchen appliance with a typical usage hours and efficiency levels in India. Now, this 90 units, which is occupied by 80% households in India, this is 3/4 of average monthly household consumption in China. That means China has much more consumption than India. 1/10 of that in USA. So USA has nearly 10 times of our consumption. And 1/3 of world average. So we are on, if you take the average of the world, we are behind that also. So if we are having such less energy consumption, then why am I teaching you about energy conservation? Yes, it is still required. Why? Let's go to this table. One electrified household in Delhi consumes about 250 to 270. What was the average of India in the last slide? It was 90. That is, let's go to Delhi. It is 250 to 270 units per month. Approximately same average amount consumed by electrified household in Germany. Now such a contrasting situation. On an average, India, on the previous slide, India was like 1/3 of the global average, and now on this slide, India is as good as Germany. A part of India, that is Delhi, is as good as Germany. Why? This is due to high ownership of air conditioners. 12% of the total households in Delhi have air conditioners. Air coolers, nearly 70%, and tariff subsidies in Delhi. Okay, so it's not that India is consuming less. The average has gone down, and those average figures are again, they can be manipulated. But it is a fact that we are consuming quite a lot of energy, right? So let's have some more look at some more statistics. Now, this is how buildings are consumed. Okay? In Industry 49, 80%. In buildings, how the consumption is 29%. If I just take at structures, okay, in these buildings, 69% is residential and commercial is 31%. So majority of the buildings are in residential sectors. Now, in a residential building, how is the utilization of this electricity? I have just enlarged this, have a look at this. Lighting is around 22%. 19% is refrigeration and freezers. TV is 15%. Air conditioning is 10%. If you go to any house, people are most careful about closing the doors. ACs on, close the doors. ACs on, close the windows. But ACs are only consuming 10%. Lighting is consuming 22%. 19% is refrigeration. Pools, spas, dishwashers, laundry, water heating, space heating, miscellaneous appliances. So, clearly we are having a misguiding. Nobody is very meticulous about switching off the lights and fans, is refrigeration, so we cannot switch it off also in any case. So how do we actually conserve this energy, right? So how do we do it? Let's understand. We need energy audits to reduce operating cost, right? The bill that we are paying to government through electricity as well as water bill, okay? Both these require to be reduced. Environmental impacts, okay? Although we said around 80% of India is having energy, 20% of India will be constituting like I don't know how many number of countries. And when we say 20% of India is still not having electricity, we're talking about a lot of people. So that again is a thought. It's a very important thought. You cannot escape those 20% people. Environmental impacts is when we are wasting energy. Energy is a very, you can say right now, it's one of the most important resource. Why do we consider Gulf countries to be rich? It's because they are having oil. They have oil deposits, so they are rich. We are still dependent on the oil and the other conventional sources of energy, the non-renewable sources of energy. Right? The day we are energy independent, we become the developed country. Right now we are not energy dependent. So we need to focus more on the renewable sources of energy, may it be solar, may it be wind, may it be tidal. And India has such a diverse topography that we can always capture from all the domains, right? When we use energy, it's the right term would be when we abuse the energy. There will be environmental impacts associated with it, right? Also, increasing economic competitiveness. Just as I said, the moment you are energy independent, you automatically go towards the developed. You are a part of a developed world, right? And we also need energy audit to decrease pollution. Why do we need it to decrease pollution? The moment we do energy audit, automatically we are conserving energy. Energy is available, and then we are not dependent on those non-renewable sources of energy which are causing pollution, air as well as water, right? So it's although it is at the 4th position in the outcomes of energy audit, it is one of the most important reasons why we need energy audit, because we want to take away the load on the non-renewable sources of energy, right? So what are the steps involved in energy audit? First is facility and utility data analysis. What do you mean by this? So now when you're doing facility and utility data analysis, basically you're trying to understand where are you actually consuming energy. So you will need at least 3 years of utility data. Now what is utility data? Utility means water and electricity bills. Okay, you have to identify the fuel types. What will be the types of fuels you will be using? Electricity, then gas, natural gas, then oil, etc. It's different types of fuel that account for your bills. Then is a walkthrough survey. So what is a walkthrough survey? Is now you have already collected the paperwork. all the bills of the previous years. You have identified when are the peak times when the bills are shooting up, and then when are the peak time when the demand is shooting up. Meaning, if there is let's say a particular type of fuel which is being used, let's say electricity, when is it actually shooting up? And let's say if it is shooting up in the month of May, then what is the reason and how can we actually alter this pattern, right? So after all this is done, then the next thing is walkthrough survey. Okay, so walkthrough survey is you will go and you will understand the concern, you will understand the requirements. Okay, you will understand the current operating and maintenance procedures. How are we maintaining our households, right? Or first question will be, are we maintaining the households or we are just letting everything run by itself? It's like automatic work. Then we also try to understand the major energy use equipments, which one are actually consuming maximum energy, whether it is lighting or whether it is HVAC. HVAC means your air conditioning, okay, or there are some motors which are being used, which are consuming more energy. Okay, so whatever is a typical equipment. Then we try to estimate the occupancy, the equipment, and lighting. So we understand what is the energy use in terms of density and hours, when it is shooting up, and when is the time required also is shooting. Okay, and then the next step is baseline for energy use. Excuse my typographicals. So now when we are trying to create a baseline for energy use, what we do is we first obtain the architectural, mechanical, all the types of, or electrical, all the types of drawings we first collected. Then we inspect, we test, and we evaluate the building equipments, whether they are performing fine or they require change. Now again, when you are saying you require change, whether the change required is immediate or maybe by just carrying out some simple maintenance procedures, we can cut down the cost. Okay, we also check on the reliability. We try to collect all the schedules for equipments, okay, and then create a baseline model. How much should be a consistent energy usage and how much above the baseline are we? Okay, then we try to evaluate energy saving measures. Now this is the most important. Evaluation of energy saving measures will be a very detailed procedure. Now first thing that we come across while evaluating energy saving measures is building envelope. Now what do you mean by building envelope? Envelope means something that is covering or rather closing a structure. See, my building envelope, let's say for our college, will be the laterite walls, okay, the type of windows, wherever there is entry and exit of air, okay. So that building envelope we need to assess. I'll be embedding a video on how actually energy audit is conducted. Now this is not an Indian video, but you will see the different types of sensors that the gentleman is holding. Okay, he has a thermal camera which takes images in infrared band. So it identifies which wall is cooler, which wall is hot. If some wall is very hot and you have put an air conditioner in the room and one wall is getting heated, then what will happen? The load on your air conditioner will increase. So then what do? Then we'll have to see that somehow we insulate that wall. We provide some kind of coating so that the wall remains cool, such that the load on my AC is reduced. If there is a leakage, let's say every time our parents keep on telling us close the door, AC is on. Now closing door just doesn't suffice. If you are going to put the AC on for 8 hours and 12 hours, then just closing the doors will not suffice. You'll have to even conceal the gaps in between. So you may have to fill the gaps between the door frames and the door shutter and the wall, maybe by a cork or a cement grout paste. You must have realized that when we walk into the old Goan houses, we feel suddenly the temperatures go down, especially when we walk into these laterite houses or the brick houses which are not covered. If you go to arid areas, like let's say you go to the central India, Nagpur area, or even if you go to Punjab and all those places, they have bricks without plaster. So now these materials like bricks and laterites, they have the inherent property of absorbing heat. So if it's very hot, they will keep the indoors cooler. And if it's extremely cool, then the absorbed energy, they will release it out. So they kind of, it's natural mechanism of air conditioning. But what we have done now, we are running after looks and we have started covering the walls with plaster. Now what plaster is this? This is not the old plaster that we used to use. Earlier time we used to use plaster made out of lime. Now we make everything in cement. Cement always gives out exothermic reaction and it gives out heat, right? So even if you just want to change this cement plaster, if you change the cement plaster to maybe mud plaster or maybe lime plaster, these plasters which have been used in the olden times, as long as of course they are not creating problems for you, like there should be no water retention or there should not be cracks formation, but there are options available. If you look at those options, it's also said that lime gets down the temperature of the indoors down to even around 7 to 8 degrees. Now, when you will study further on in your building construction subject, you will understand when you are studying air conditioning that a comfort temperature will be not less than 8 degrees. So let's say outside it is 30 degrees temperature. Your AC should not be less than 22. You understand? It cannot be less than 8 degrees. Or let's say you are in an extremely cold climate. You are in Kashmir or some other place. Your heater should not be plus 8 degrees. The reason being, when you have such drastic change in the temperatures, your health is always going to get affected. Now we in Goa sometimes, our temperatures are like 36 and 35 outside. And when we keep our AC to 18 and 20 degrees, then we are going to invite some or the other health problem. Now when I say that lime plaster or lime mortar is going to automatically bring down the temperature by 7 degrees, you are actually eliminating the need of artificial air conditioning. So, but we have absolutely, completely eliminated that particular method of construction. We need to be more aware about how the building envelope can be altered in order to have energy savings. So what we did, we constructed cement structures, concrete structures. I'm not saying you should not use cement. Obviously, it has way more advantages than the disadvantages. But in certain places, the usage can be minimized, right? So if we just change the type of building blocks that we are using, or the type of covering or coating on the facades, then our requirement of energy can go down. If you people have heard about light wells, just as you have water wells, there is a concept of light well. So if you have a staircase, what is there at the ceiling of the staircase? Anybody can think. Obviously, your staircase will be leading from ground floor to the top floor. At no point in the staircase, you are going to walk over the staircase. If you are in one room, you can be walking over the ceiling of that room on the first floor. The first floor ceiling can be used by the second floor as the flooring, correct? No? But that doesn't happen in case of in case of staircases. Many a times the staircase right on top we have a slab. Now what is the use of that slab? Most of the time it's of no use. There's nobody going to walk over it or go and sit over it. Now in some places architects have come up with this very innovative concept of replacing that slab which is over your staircase wall with just a glass or maybe a FRP sheet which allows for light to come inside. So obviously your staircase way is not a private area. So you don't need dark place there. You don't need an entry and exit, right? So all that place can be always lit. It can be well lit. So now what we are going to do, we are going to provide a slab over it, close the entry of light. Then we are going to construct windows somewhere on the walls. So we are going to again create cost implications. And then we are going to fix the light fixtures to give the artificial light. And sometimes, I've seen people using light even during the daytime in the stairways. So that a simple thing like replacing the slab with a FRP sheet does a lot of energy savings. right? So also when we talk about building envelope, we are also talking about doors and windows. Okay. Wherever possible, we should try to have bigger windows so that the light entering the house is ample, good enough during the daytime, and you're not dependent on the artificial lighting sources, right? Then ventilation, indoor air quality. We a lot of times we talk about Vastu Shastra. A lot of Indians believe on Vastu Shastra. But what is Vastu Shastra? It's basically the science of entry and exit of light and air. You keep your house well ventilated. You keep your windows positioned in such a way that the foul gases will not enter the house. Here you keep your doors positioned in such a way that there is cross ventilation. That's all it talks about. You keep your living rooms and kitchens in the directions where sun is going to rise, and bedrooms in the direction where sun is going to set. It's that easy to understand. But we always try to do something ulta, and then we depend on the artificial sources of light as well as air. Okay, again, electrical systems, these also play a very important role in energy savings. Okay, you have to tap for the energy leakages. You have to go for those appliances. Now there are appliances which come with star ratings. Anything which is 5-star rating is going to be definitely costly, but eventually in the long run it's going to cut down your bills. Right? You have to be concentrating on the day lighting. The plan should be such, your plan of your house should be such that during the daytime maximum light enters in the common areas. Now if you are doing energy audit for something which is already constructed, then obviously you cannot alter the plan. You don't have much scope to do that. However, if you can change the facades, let's say if you have a window and if you can try to have a more transparent facade, then your job is done. You are less dependent on the electrical sources. HVAC actually talks about your air conditioning. Okay, I just spoke. If you will go through the video that is embedded in the description, there the gentleman is telling you when you have a window, around the window, there is always chances of air coming in or going out. So all these gaps have to be sealed in. Your ceilings, your doors have to be well insulated. Okay. Then indoor water management. Now, how is water management actually linked with energy savings? See, when we are consuming water, that water is eventually pumped. It is pumped to our houses. Okay, more we consume, more needs to be pumped on the overhead tanks. Now, there are certain places in metropolitan cities that they are making use of, we use these showers. Now, there are places where there are pumps installed for the showers, such that the water comes out in the form of a very, very fine droplets like mist. In a half a bucket, you can have a regular 2 to 3 minute shower. Just in half a bucket, you are clean enough. So people are very cautious about water management everywhere now. It's high time that we also understand the requirement. They say the next war is going to be war because of water crisis. So before such situation comes, we should understand how to manage water. A lot of people in civil industry or construction industry do not know that there are specific taps for specific purpose. You cannot be putting any tap in the sink, any tap in the wash basin, any tap near your bucket. The taps have a discharge volume, how much water they should be discharging in a minute. A shower which is giving heavy volume of water, let's say 10 liters in a minute, you don't require that much. Now, it's have you all ever seen anybody very cautiously opening the tap? Or you ever try to note down the people who are washing the utensils and it's always either full or closed. Actually, you don't require that much of volume of water. And in fact, in developed countries, people are very cautious. In fact, the manufacturers here itself are not aware that you have to manufacture sink taps to the requirement of sink discharge. When you're manufacturing a tap for wash basin, it doesn't require to discharge huge volumes of water in a minute. Because when we open, we are not going to meticulously calibratedly open. The top we are going to give is like, randomly we'll just open it fully and then we'll close it. Now the water that is coming out, most of the time we don't need that much of flow. Half of the flow is also sufficient to wash the hands. But we're not really cautious about it. So when the water consumption will go down, water requirement will go down. So every time you are saving water, saving energy, it's as good as you are generating water, generating energy. You are going to be independent in future, right? So this is all I wanted to talk about in terms of energy saving measures. Okay, so have a thought about all these things, and there's a link that I've provided. Kindly go through the video, and I will be eventually putting a test, a small test, a objective quiz. Try to answer that quiz. Thank you so much.